Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 695, max area of island. We're told that we're given an n by n binary matrix grid, and an island is a group of ones representing land connected four directionally, and we have to assume that all four edges of the grid are surrounded by water. And the area of our island is the number of cells where the value is 1, and we need to return the maximum area of an island in the grid, and if there is no island, we just return 0. Okay, so in this example, we return 6 because we're given this grid, and the biggest island is basically the biggest block of cells, which all have the value 1, is the length of 6. So we have an island with 6 cells, so we return 6. In this example, we return 0 because there are no islands. So if you've solved the Leetcode 200 problem number of islands, this problem will be quite a lot easier. So I'll hop straight into the code. We want to first check if the grid doesn't exist. If there is no grid, then we just return 0. So if we've got an empty grid, we just return 0. Otherwise, we need to get the number of rows and columns in our grid. So we're going to say length of grid, and length of the first row in the grid is going to give us the number of columns. And then we can also have max area, which is going to be equal to 0 initially. And then we're going to say for each row in range rows and for each column in our grid, let's say if grid RC, so if our current column equals 1, well, we know we found an island, so we can say max area, and we're going to be using depth first search to get the count of the landmass. So we're going to say max area is going to be equal to depth first search, or actually it's going to be equal to max of max area and depth first search, and we're going to pass in our coordinates of our cell. So let's write up our depth first search function. So right now everything has been pretty much the same as Leetcode 200 number of islands. Now we're going to change it up just a tad bit. So let's create our depth first search function, takes in a row and takes in a column, and we want to check if we're going to check our base case. So this is going to be our recursive base case, and this is basically just going to check, are we out of bounds or have we come across a cell of water? So if R is less than 0, or C is less than 0, or R is greater than or equal to rows, or C is greater than or equal to cols, or grid RC is equal to 0. In this case, we've reached our base case, so we return 0. Otherwise, we can mark our current cell as 0, so we're going to mark it as water because we don't want to keep counting the same cells over and over once we've visited them. And actually before that, let's set the area initially. Actually no, we can set the area down below. It doesn't really matter. But our initial area now is going to be 1. And now, as with any other depth first search function, we need to increment our area count recursively. So we're going to say area plus equals depth first search. We're going to do R plus 1 and C, so we need to do top. I'm going to copy this a couple of times. Top, bottom, right, and left. Boom. Okay. So, and we need to return the area as well once we've done. Can't forget that. And now that's our depth first search function written. So once we've traversed the entire grid, then we can just return our max area, and that should be all the code unless I've made a mistake somewhere. And I've not. So we pass all 728 test cases with an optimal solution. So again, this problem is a lot easier if you've solved Leetcode 200 number of islands, because it's pretty much the same apart from changing the depth first search function. So in terms of time complexity, we're looking at an O of n squared time complexity and same with space complexity. Because of the recursive call stack, it's going to be an O of n squared space complexity as well. So I hope you guys enjoyed this video, and I'll catch you in the next one.